Let's wait for this network to come up here. So in the last video, we covered standard access control lists and how you configure them. And the one thing we didn't talk about is, how to erase and redo your access control list if you make any mistakes with them. Let's hop back into here. So if we're writing out our access control list, we get like access list 10, deny any. So we're going to say deny any traffic. Let's say the next thing we want to put in was access list 10 permit, and we would say we want to permit that first PCV LAN. So we're going to put 192.168.10.0. Put in our wildcard mask there. And let's do a do show run so we can look at this. So here are our two statements for our access control list. So what's important to remember, again, when your router is comparing your traffic and processing it against an access control list, it's going to process it in sequential order from top to bottom. And as soon as it matches any traffic that matches that access list, it's going to apply that rule and stop processing. So in this example, this any marker here means any traffic coming through, and it's the first thing on the list. So it's going to process all traffic, because if anything, everything's going to match, it's going to deny, and it's not going to hop down to this next layer here and keep looking for something to match. That's important to remember. So the order in which you put these in is really important. You want to do it thinking of like a pyramid style. You want the most accurate or the smallest scope up top, and as you get down lower into your pyramid, into your access list, you want the more broad rules. So this one's messed up because we have the broadest rule and any rule right on top. So no matter what, the traffic is never going to get be compared to this list here of checking to see if it's the .10 network and see if it's allowed. Everything is going to hit this deny and then be dropped. So if we need to remove that access list, there's no way to go in and edit line by line your access list. That's the one feature really where Cisco command line fails compared to a GUI. Everything else you can accomplish much faster in a command line setting. If you go into modern routers like you have a pfSense or a Sophos or something like that, you have a nice GUI graphical interface where you can click and drag your access rules around and kind of figure out what works best for you. With Cisco, you got to do it right the first time here in the command line. And the only way to start over again is to remove that access list and try again. And that command is no access list 10. And that will remove it. So let's do a do show run. Take a look. Yep, so that's gone now. No more access list available for us. So what we're going to work on now is going to be an extended access list. So extended access lists are different from your standard access list. Not only because of where you apply them, where a standard access list, you want to apply it at the router interface that is closest to the destination. So if we have our network here, our PCV LAN 10 is trying to go through our network and reach the laptop VLAN 60, the closest destination port on a router is that gigabit sub interface right there. That's why you want to put standard access lists. Extended access lists are the opposite of that. You want to apply them closest to the source of the traffic. So in this case, again, this PC VLAN is trying to reach the laptop VLAN. The closest source address would be this gigabit interface on this router right here. So let's hop into that one, and we'll write an extended access list to accomplish our goals. And, before we keep getting into this, I want to make it clear there's no hard and fast rule when you're setting your access control list, doing standards or extendeds or, how you order them, which numbers you make them, etc. And you won't be graded as such. It's as long as your access lists accomplish the goal you need them to do, then it is correct. It's not like, DHCP where you have to have your settings right or it's not going to work. It's not like VLANs where you have to have your settings right or it's not going to work. You could do any sort of combination of extendeds and standards to achieve the network security level you want. So with that in mind, going into your final exam here, don't be too concerned if you think to be thinking what kind of access list you should be using. Think about what makes sense to you, and if it works, it works. So let's hop into this router here. Enable conf t. And just like we were saying, standard access list, it's access list. The only difference here is we're going to choose a higher number. So when you choose from 1 to 99 for your identifier there, it's going to be a standard access list. But if you choose from 100 to 199, that'll make an extended access list. And you don't have to, but I would recommend, like we've been doing all year, keep everything so it kind of makes sense here. We did VLAN 10 going into subinterface 10 with a DHCP pool that was called VLAN 10. So it makes sense that we should keep our access list in 10 since it's going to apply to that and go 110. Same deal here with the next statement with extended access list. They want a permit or a deny statement. And we're going to be denying traffic going through this router trying to reach this laptop address. So we're going to do a deny. Do a question mark. There's the big difference here, or one of them, between extended access lists and standards. You need to specify which type of protocol you are going to block or permit. So it's not like we're extended standard access lists where you just are choosing which network you're going to block or deny or permit. You're going to be choosing the protocol. We're going to be choosing ICMP because the internet control message protocol, that's your pings. That's what we're going to use to test our access lists are actually working. So we want to block ICMP. If you block IP traffic, which is IP or TCP or UDP, which is a more real world scenario that you would use, you're going to be able to ping across your network, and it's going to be more difficult to troubleshoot your network and find out if your access controllers are doing what you want them to do. So we're going to pick ICMP, and we'll do that for the final. And let's put in a question mark. And you see it looks like it's asking for another 4-octet address, an IPv4 address. But notice here it says source address. So with extended access control lists, you block by source address trying to go to a destination address. And the first thing we're going to type here is the source address. So we're going to be blocking that VLAN 10 here. So we're going to be 192.168.10.0. Question mark that up. It wants another wildcard mask. So again, 0.0.0.255. Because the zeros, think of those, that means match this. So match that first octet, 192. Match the second, 168. Match the third there, .10. And the 255 means match anything. So you don't always have to use that 255 either. That's, if you're thinking of it the opposite of subnet mask, really, you could use a .128 and block only half of that network, or a subnet of itself, not the whole section, or you could do a .192 and block 62 hosts. But in this case, we're blocking the entire network there, .255. Do another question mark. And you see now it wants the destination address. So where is this network, the source, where is it trying to go to? And we're going to pick this laptop VLAN here that we don't want it to get access to. 192.168.40.0. And once again, it's going to want a wildcard mask. And we're saying match the first 3 octets and anything in that last octet. And enter. So this whole thing says right here on access list 10, deny ICMP traffic that is coming from the .10 network leading to the .40 network. So we need to do this again because we're blocking this access on this this VLAN right now, but we also want to block it on that network. So we can just hit up, or we can retype it all up. Let's do access list 110, deny ICMP traffic coming from that VLAN 10. Heading towards our VLAN 60 address. And again, with the wildcard mask there, we're saying match the first 3 octets, anything in the 4th octet. Enter. So let's do a do show run. Let's take a look at our access control list here. So when we apply this to an interface, we've got the top part of the pyramid correct here. We have very specific blocking that we are doing. We're blocking access list, access list 110 is denying ICMP traffic from the .10 network going to the .40 network and the .60 network. The problem is, again, with access control lists, If the traffic does not match as it's going down and comparing through your list, it doesn't match anything in here, there is that implicit deny. So if we were to apply this access list right now, it doesn't matter that we properly have these two laptop networks blocked like they should be, because we're not permitting anything else in here. There's an implicit deny involved. So we could go back in here and let's hit up here. We could do a access list 110 permit ICMP and go through here and say permit this PC group to talk to this laptop because that's what we want, the same broadcast domain, and then go permit talk to this group and permit talk to this group and permit talk to this one and permit talk to this one. And, in a real world environment, best security practices is to only allow traffic where it really should be. But we're doing, a really simple lab here. So we're going to make life much easier for ourselves when you do this on the final two. We're just going to permit ICMP any. And notice on this one, we're doing two any's because the first any is the source address and the second any is the destination address. Let's do a do show run again. Let's look at this. So now when we apply this access control list, our traffic's actually going to respond like we think it should, because traffic, for instance, if we're coming from this PC to this PC group, it's going to process sequentially through the list and it's going to say, okay, you are the 110 network, but you're not trying to go to 40. Okay, that doesn't apply to you. Next list. Okay, you are the 10 network, but you're not trying to go to 60. Okay, next. Okay, you are any network trying to go to any network. Okay, and you're permitted. So we can apply this now. So let's hop into our sub interface here. And because we kept with, we got to standardize our naming conventions. We know VLAN 10 on network 10. We know our sub interface is going to be 10. That's how we configure it. So we can go interface gigabit 0/1.10. And the command to apply your access list now is IP access group. Your access list number. And once again, here's to a question mark. You have to choose between in or out. So think of how the traffic that you want to filter is flowing through your network. We want to block PC traffic trying to come up through our router across the network and down to either of these laptop groups. But as far as this little interface right here, your sub interface 0/1.10 is concerned, the traffic hasn't gone into the router yet. It's trying to go up and in the router. If we were doing a standard access list and maybe applying it right here on the serial interface, it would already be in the interface and trying to leave. So remember that in and out. If it's already inside the router and it's trying to leave, you want to do outbound packets. But in this case, it's still on a segment trying to get into the router. So it's in, is how we want to apply it. Let's exit out of here. And let's take a look at the traffic here. .2, so everything should be .2s here. So we didn't block any IP addresses in our DHCP. Let's go in here, ping 192.168.20.2. First one here should be an ARP and should fail. Then we should see our next one successfully. There we go. We should be able to ping other PC groups, so the 30.2. There we go. But we should not be able to reach a laptop group in the 40.2. There we go, destination host unreachable. So that is how you set extended access control lists. So it's important to remember when you're going through here, start with your most restrictive settings first, and at the end, do not forget about the implicit deny all. So if you haven't permitted the traffic you want to allow through the network, either through a more specific permit this particular network or broader permit any, the traffic will be dropped by that implicit deny by default.